In this video I'm going to give you an example of when the limit doesn't exist. So let's say you've got a surface looking like this. So punch this into a 3D graphical plotter. It will then give you this surface. So as you approach the origin, as x and y approaches the origin, the limit of this, you can see that, imagine you're an ant located at here. So as you head towards the origin, you can see that you're heading towards an elevation of let's imagine this has an elevation of 1. But then if you approach the origin from, so if you're an ant, let's say you're an ant here, you're going downhill, downhill, and then let's say you're approaching the origin here. Now as you're approaching the origin, you can see that you're at an elevation of not 1. Let's just imagine it to be -1. So here the limit doesn't exist, because the whole point of a limit existing is that no matter how you approach the origin, it should head towards the same elevation. Here you're heading to an elevation of, let's say, 1, and if you approach it in this path, then you're heading towards an elevation of -1. So when given a surface, in your mind picture this. In your mind picture the xy domain. So you can approach the origin. No matter how you approach the origin, it should head towards the same elevation. If you approach it this side, then it should head towards the same elevation. If you approach it here, then you should, if the limit truly exists, then it should head towards the same elevation. But in our case, if you approach it from this direction, it will give you an elevation of 1. And then if you approach it from this direction, then it will give you an elevation of -1. So we can conclude that the limit does not exist. But in reality, you won't have the luxury of drawing this surface. So we can still analyze it even if you don't have this this plotter. So what you do is if you look at this, let's just look at this plane here. So this is y equals 1, this is y equals 2, this is y equals -1. Imagine you're at the plane y equals 0. So you put 0 into here. So what that means is y equals 0 is along here. Is along here. Hang on, is along here. So now you've got to imagine you've got a vertical sheet of paper. And so imagine you've got a vertical sheet of paper looking like this. So this has an elevation of 1, 2, and then this here is -1, -2, and so on. So imagine you've got a vertical sheet of paper looking like this. So on where the vertical sheet of paper intersects with the surface, it will look like this. It will look like this. So imagine your face is over here. Imagine your face is over here, looking in this direction. So so on the right, so this bit here is the x-axis, pointing in the positive direction. So that's this bit here, pointing in the positive direction. And then your face is here, looking directly here. If you move to your left, then you're heading in the negative direction. That's this direction here. And then the height is your elevation, z. So so where the vertical sheet of paper intersects with the surface, it will look something like this with this equation, because when you put y equals 0 into here, then this whole equation here will then become this. Well, what you've got down here is when you put 0 into the y. When you put 0 into the y, this thing here disappears, leaving you with -x over square root of x squared. Square root of x squared, you can imagine it as being the absolute value of x. So so it will give you this thing here. Now if you look at this, let's say you're at -1. So when you put -1 into here, -1 would be +1, and then down here you're ignoring the absolute value of -1 is 1. So that's why you have an elevation of 1. And then if you put, let's say, 2 into here, hang on, let me put 2 into here, put 2 into here, so that would be -2, divided by absolute value of 2 is 2. That's why you have an elevation of -1, which is here, -1. So you're down here. So anyway, it will look like this. So as you approach the origin as x up, well, let me start again. Sorry, y equals 0. You put it into here, and then this will then become limit negative x over x squared, because you put 0 into the y, it disappears. By right, I should write this: x, y heads towards 0, 0. But y is no longer there, y is absent. So let me just simplify this and just say as x heads towards 0. So this thing here is exactly the same as this for this given plane. So now you can see that the limit here, you can clearly see that the limit doesn't exist. Well, this is 1, this is -1. So we can conclude the limit does not exist. Okay?